In the previous lecture, we have derived the time period for the compound pendulum. So it is as per this equation, time period is equal to 2 pi square root k square plus h square divided by gh, where k is radius of gyration, h is the distance of point of hanging to the CG, g is gravitational acceleration, which is 9.81, what we already know. Now what we are interested in finding k. So let us square this equation both the side. T square is equal to 4 pi square, and here the square root will be removed, k square plus h square divided by gh. Now let us put this 4 pi square to this side, so this will be 4 pi square, and here we can remove it. Similarly, let us transfer gh to the other side, so here you can write t by 2 pi whole square, t square by 4 square, so I am putting it in the square, and gh will be here, so gh is equal to k square plus h square. Now rewriting this equation in this form, k square is equal to t square by 2 pi into gh minus h square. So k is equal to everything in square root, so this will be square root of t by 2 pi whole square into gh minus h square. So this is the equation using which we can find out radius of gyration for the object. So what we need to find, if we know time period, if we know g, if we know h, then we can definitely find k. So this is the base for this experiment. So in this experiment, what we will do, we will hang a bar from a point of hanging. Say suppose it is hanging from this point, and here a g is located. So take this different distance h. Suppose here I have taken h1, and it will be oscillated about this point. Say for example, if we oscillate this for 10 oscillations, then we will find t1 for 10 oscillations. Say it is 9.8 seconds. So t1 for one oscillation, it will be divided by 10, so 0.98 second for brevity and for clarity. So now you have t1 with you, you have h1 with you. Put this in this equation as h1 and t1. We will be having k1. Similarly, if we change the point of hanging, say now h2, means we have to move this whole plate to upside. So newer h2 is this. Similarly, you need to find newer t2 for 10 oscillations. Out of that, we need to find t2. And now we have to put h2 and t2 in this equation. h2 as t2, and we will find here k2. And we need to check whether k1, k2, k3 all are changing or not. So similarly, we'll take minimum 4 readings and we'll prepare a table using which we will find k.